Okay, so we're finishing off our 11.4 notes. So we're doing day 2. The first thing we're going to talk about is events. Life is full of random events. The toss of a coin, throwing a dice, and lottery draws are all examples of random events. They can be dependent events, so an event that depends on what happened before. So if you take a card from a deck and you leave less cards in the deck, that's a dependent event. Or independent events, things that are not affected by the previous events. So the probability of an event happening is found by taking the ways it can happen and dividing by the total number of outcomes. Okay, so A says a jar contains 12 green marbles and 8 violet marbles. A marble is chosen at random from the jar and replaced. This is going to be my keyword, replaced. Another marble is chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? So the first thing I want to do is figure out how many total marbles do I have. 20. I'm going to take 12 plus 8. So for my first choice, if I'm doing P of G, that means probability of green. What's my probability of getting a green marble? How many possible greens are there?
12.
Out of? Okay, so then I just want to simplify my fraction. Remember to do that. On my calculator, I type in 12 divided by 20, and then I want to press the math button, and then my first choice fraction, and then enter one more time, and it gives me 3/5. So, assuming I've chosen a green marble for my first one, it says I'm replacing the marble. So that means once I choose it, I write down the color, and then I put it back in the jar. So when I go to choose my second marble, what's the probability of it being green? Yeah, I still have 12 out of 20, or 3/5, or 60%. Because still the same number of marbles in the jar. Okay, so the probability of violet, what is that? 8 out of 20, which simplifies to 2/5. And then when I go to pull a second marble out of the jar, what's my probability for violet? The same, because I still have the same marbles I'm choosing from. So it's also 2/5. So, we've already said the probabilities are the same. The first color does not affect the second. That means these are independent events. Okay. So B says a marble is chosen from random out of jar and not replaced. So once I take it out, I leave it out. Another marble is chosen at random from the jar. Does the color of the first marble affect this possible outcomes for the second? So I have my first choice. So I can either get green, which we said was 3/5, or I can get violet, which we said was 2/5. So then I'm going to use a flow chart to help me get my events here. If my first choice was green, what is my probability of getting another green out of there? So I've taken one marble out and I've put it off to the side. How many green marbles are left? 11 out of how many total marbles are left? Are there still 20 in the jar? I took one out and put it off to the side. 19. Okay. What's my probability of getting a violet marble for my second pool? How many violet marbles are left after I take out a green one? 8 out of how many total? 19. So I'm going to do the same thing for my second choice, but this time I'm looking at if I pulled a violet first. What's my probability of getting a green? So how many green marbles are left if I've taken a violet one out? How many? 12 out of 19. And then my probability of a violet, how many of those are left? So, notice my fractions are not the same as my first pool. So, when the first marble is not replaced in the jar, the color of the first does affect the probability of the second. That makes these dependent events. Okay, so the next thing we're looking at is our probability of independent events. So if I know that my two events are independent, then the probability of A and B is found by taking the probability of A and multiplying by the probability of B. So, what is the probability of rolling a 4 on a dice and getting a tails from tossing a coin? So, my first event is rolling a 4. And my second event is getting a tails. So what's my probability of rolling a 4 on a dice?
1 out of 6.
And then my probability of getting a tails on a coin?
1 out of 2.
1 out of 2. So to find the probability of doing both, I'm going to multiply my two fractions together. So I'm going to take 1/6 times 1/2. So if I'm multiplying by hand, remember you multiply fractions by multiplying straight across. What's 1 times 1? And then 6 times 2? 12. So I have 1/12, and then if I find that on the calculator, what is that as a percent? Okay, so remember you take your decimal and multiply by 100. So it's 8.3%. Our next problem says Alex cannot decide which shirt to wear today. Out of her 4 shirts, she has 2 yellow, 1 blue, and 1 green. She chooses one at random. Then there's also a probability of rain today, 40% or 2/5. So do these two events affect each other? No. So I want to find the probability that she chooses a yellow shirt and it does not rain. So what's the probability of choosing a yellow shirt? How many yellow shirts does she have? Out of? So that simplifies to 1/2. And then the probability of not raining. Did it give me the probability of it not raining? No, it gave me the probability of raining. So how do I find the chance of it not raining?
1 minus the chance it will rain.
Yeah. So I'm going to do 1 minus 2/5. And I want to use the fraction here because I have the probability of her shirt being a fraction. So what's 1 minus 2/5? No. Yeah, Ben? 3/5? So then I want to find the probability of a yellow shirt and not rain. So I'm going to take the 1/2 and multiply by the 3/5. Three tenths, which is what as a percent? Just 30. Okay, so what is the probability of a green shirt? Oh, you know what? I think I was wrong. And then the probability of rain? You're right. I was thinking green was 1/2 for some reason. And rain. So that gives me 1/10 or 10%. Sorry. I don't know what I was thinking. So the next thing we have is mutually exclusive and not mutually exclusive. Mutually exclusive are events that cannot happen at the same time. So I have examples. I can't turn left and right at the same time. I can't flip a coin and get heads and tails. I can't pick up a king and an ace if I'm looking at cards. Non-mutually exclusive events are events that can happen at the same time. So I can turn left and scratch my head. I can pick up a king and a heart. It would be the king of hearts if I did that. So, given events A and B, if A and B are mutually exclusive, then the probability of A or B is the probability of A plus the probability of B. And then if they're mutually exclusive, the probability of both happening, so A and B, is 0. There's no chance that'll happen. Okay. If they're non-mutually exclusive events, then the probability of A or B is found by taking the probability of A, adding the probability of B, and subtracting the probability of A and B, because I'm double counting something. So if I think of my example up above where I picked up a king and I wanted to pick up a heart, if I do just A plus B, I'm going to count the king of hearts twice. So I need to subtract one of those out. Okay, so it says we roll a regular 6-sided dice. What's the probability I roll an even number, or a 3 or a 5? So is this mutually exclusive or non-mutually exclusive?
Mutually exclusive.
Why?
You can't roll, you can only roll one number.
And why can't it be even in 3 and 5 at the same time?
3 and 5 aren't even.
So those can't happen at the same time. What is my first event? What's the first thing it said in the question?
Roll an even number.
An even number. or what was it? I can't spell number. What was my second event?
3 or 5.
Okay, so what's the probability of rolling an even number? How many numbers on a dice are even? 3. Right, because on a dice it goes 1, 2, 3, 4, 5, 6. And then 2, 4, and 6 are all even. Can I simplify my even fraction? 1/2. And then I have my probability of 3 or 5. So how many numbers are 3 or 5? 2 out of? So that simplifies to 1/3. So, because this is mutually exclusive, I want to take my two fractions and add them together. So I want to do 1/2 plus 1/3. No. So just add them together on my calculator. I'm going to go ahead and I'm going to type 1 divided by 2 plus 1 divided by 3. And then I'm going to press enter. It's going to give me a decimal. I want to press the math. And then I want to press enter to turn it into a fraction. And then enter one more time. And it gives me 5/6. So remember, fractions are really division when I'm typing in the calculator. What is the probability of rolling an even number or rolling a 3 or a 5? I just need to fill in this blank. 5/6. Okay, so that's what I do when they're mutually exclusive. The next thing I have is in a standard deck of cards, what's the probability of picking a red card or a 7 card? So this is where I want you to take that tiny piece of paper you picked up on your way in. The first 2 rows are red. So I have hearts are red. These ones below it are diamonds. Those are also red. Then I have spades. Those are black. And then below that I have clubs. Those are also black. So can I pick a red card that is also 7? Yes. So these are non-mutually exclusive. So how many cards are red and 7?
2.
Okay, so my first event is being a red card. And my second event is being a 7 card. So what's the probability of being red?
1/2.
Yes, 1/2 of my deck is red. The probability of being a 7, how many total 7s are there in a deck?
4.
Out of?
4 out of
52. And can I simplify that fraction?
yes, 1/3.
Okay, so since these are mutually exclusive, to find the probability of a red and 7, I'm going to add my two fractions together. So I'm going to add the 1/2 plus the 1/13. And I want to subtract how many cards I'm double counting. So how many cards are both?
2.
Out of?
52.
Okay. So if I type this into my calculator, what does it give me? sorry, this should have been red or 7. Okay, so the probability of picking up a red card or a 7 is 7 out of 13.